Hello, welcome to Organic Synthesis. So hopefully this will tie up what you've been looking at throughout the AS course. So the aim is I'll show you a starter material and a finished product. And the aim is to get from the start material to the finished product using the synthetic routes that you all know from AS chemistry. So here we go, here's the first one. So you'll see the reactant and also the product flash up. See if you can do it and then start the slide again and I'll go through the answer. Right, so here's the first one. We have got ethanol going to that product. Give it a go. See how you get on. Rightio. So how can you do this? Well, you are starting here with ethanol. And you need to make this guy. Now, the key thing you need to identify is what type of molecule is it. And, of course, you know this is an ester. So, how am I going to do it? Well, to make an ester, I need a carboxylic acid and an alcohol. Well, hey, I've got an alcohol, but not a carboxylic acid. So, what carboxylic acid do I need? Well, I need that one there, and that is going to be ethanoic acid. Now we know that if I use potassium dichromate and it's acidified and I reflux, that would give me ethanoic acid. And then what I need to do is to get to my ester, I need to add in some ethanol, like so. And I also need to use concentrated sulfuric acid as a catalyst. And that would give me the ester. Get some bonus points to be able to name it. Of course, that ester is going to be called ethyl ethanoate. Okay, cool. Let's move on to the next one. Right, so this one's a little bit trickier perhaps. You're starting with this guy here, C6H12O6, and I need to make ethanoic acid. So how can I do that? Well, give it a go. As I said, you've got to use it in 2 steps. Right, so this is how you would do it. This guy, of course, you know is glucose. So to be able to give that, if you use yeast, and it's going to be in aqueous solution, so you need to add in some water as well, and it's got to be around 38 degrees C, just to get it to work. That would give you ethanol, so CH3, CH2OH, and then we're kind of back to the previous one. To get ethanol to ethanoic acid, I, of course, am going to use potassium dichromate. That's got to be acidified. And I'm going to reflux, because it's the alcohol going all the way to the carboxylic acid. Okay, well done. Let's move on. Okay, so this one's quite tricky. You've got to do this in 3 steps. You are starting with ethane, and you need to make ethanoic acid again. Right, well, okay, here we go. What do you know about alkanes? Well, they don't do much. But one reaction that they do, they burn. Well, that's going to give me carbon dioxide and water. Not a lot of use. But they also undergo free radical substitution. So that's the one I'm going to hedge my bets on. So I'm going to use chlorine. And for that, of course, we need UV light. That would give me CH3, CH2, Cl. Okay, halogenoalkane. What can I do with my halogenoalkane? Well, with my halogenoalkane, I can react it with a sodium hydroxide solution. And I need to warm that up. And that would replace the chlorine with OH to give me ethanoic acid. Well, hey, ethanol. And now I've got to go ethanol to ethanoic acid. Easy peasy, lemon squeezy. You know this one. We've done it umpteen times. Potassium dichromate we need some acid, and we're gonna reflux it up as well. And I've got my ethanoic acid again. Okay, so here's a final question for you. You've got to convert your cyclohexene into the molecule on the right hand side. So give it a go and then start the recording again. So how are you going to do this one? Well, the first thing you need to do is you need to get rid of that double bond, but you need to introduce some sort of functional group into it that you can convert into a ketone. So the way to do that is if you add Br2. If you add your bromine, you will of course make your 1,2-dibromo cyclohexane. Once you've got your bromine on there, you can react that with sodium hydroxide solution, and that will turn your bromine into alcohol groups. So you will be making a diol. And finally, you know how to turn an alcohol into a ketone. You can add acidified potassium dichromate solution. So K2Cr2O / H plus aqueous. And you're going to reflux that because, you know, of course, you can't turn a ketone, it won't oxidize any further. It's not going to go to a carboxylic acid because it would have to be a primary alcohol to do this. And of course, this guy down here is a secondary alcohol. Okay, so well done if you got that one. That was a tricky one. And that's it for synthesis. Hope you enjoyed it.